Hey everyone, welcome back to Armchair Technician. Today we're going to be taking a look at a mid-70s Ampeg V-4 head. It's been a long time since our last video, so we're going to get right back into it with a little bit of history. After the success of the SVT line of bass amps in the late 1960s, the Ampeg Corporation introduced the V-series of guitar amps in 1971. Big rock guitarists such as Keith Richards were asking for more volume and cleaner headroom from their stage amps during the stadium tours of the day. The V-4 provided all of that and more. With then state-of-the-art tone controls, an ultra-linear circuit design, and onboard spring reverb, the V-4 was and is one of the most versatile tube guitar amps ever produced. Alright, so we've got this removed from the enclosure and we're just taking a look at the underside of it here. Now, for a cap job on this amp, it's got 3 of these can caps on the bottom. That's what these are, capacitors. These are not vacuum tubes, as sometimes people confuse these with tubes, but they are not. We're going to remove these, and we've got a really nice replacement set here for these 3 can capacitors. These are from fliptops.net. They're the only place that I've found that has the correct size and component value to replace the caps in these old Ampegs. I like these because they have the correct values and the size is the same as well, so it's pretty much just a straight swap. You don't have to make any mods to the amp. And fliptops.net is the only place on the internet that I've found that stocks these. They're a little bit expensive, but I think they're worth it in the long run. And one cool thing about these old Ampegs is that they make it really easy for you to access the components. This panel, obviously, it has some bolts that hold it down, but they come off easily and you can just lift this away and it exposes the components here on the board. And the kit from fliptops.net also includes these 2 caps here. These are the bias caps. We're going to change those out. And on our top side gut shot here, these are the 2 of the 3 can caps that we're going to replace. You can see this is the bottom side of those. It's kind of hard to see, but this is the other one. It's hanging out over here by itself. It's underneath this big 10-watt resistor here. We're going to replace this one, and we're going to replace this one as well. So that is, I guess, a total of 6 different individual units that we're going to replace on this amp. Also, this power switch is not working right. It won't switch off, so it's forever in the on position. So we're going to change this one out. This is a very simple single pole, single throw switch, and I've got one of these on hand, so I think it'll work well. It's pretty standard stuff. And when we're done with all of that, we're going to retube, or at least retube the power section with this matched quad of 7581As. This amp originally had 7027s in it, but these are all part of the same sort of general 6L6GC family of tubes. We will have to adjust the bias. It's not super convenient to adjust the bias in these amps. They weren't outfitted with trim pot control for that. So we're going to have to do it the old-fashioned way, but we'll get into that later. And yeah, you can see in the tiny little writing here that the original schematic calls for the 7027A, but we'll talk about the differences between those and the 7581As later in the video. Alright, first of all, we're just going to knock out this switch replacement here. Now this is a single pole, single throw switch. I'm not going to get into exactly what that means, but this is really the most simple of all switches, just basic on-off functions. It has 2 leads on the switch, and it doesn't even matter which wire goes to which side. So this is just a super easy replacement. And I have this brand new unused single pole, single throw switch here. Just a simple toggle on off. And it's got the same voltage rating and everything as the original, so we're all good. And it's going to look pretty good in the chassis. So I'm just going to switch this out real quick. Alright, now we've got this new switch wired up, and we're just going to install it to the faceplate of the chassis. Alright, so we got this power switch installed successfully, and I'm just going to move on now to our real job. Okay, now the most important thing when you're doing a job like this is making sure that you stay organized. We're going to remove these 2 caps first. We're going to do them one at a time. That's an important part, is just working one component at a time. Also, there's a lot of wires that are going to and from the leads on these multi-stage caps. So you can do it one of 2 ways. One way is to, when you remove the wires, I'm going to put a piece of tape on each wire that tells me where it's supposed to go on the new component that we're going to install. And you can also take pictures, which kind of gets confusing sometimes. You can also draw a diagram with all the little symbols and components. I don't know, whatever works best for you, but this is a working amp, so we're not trying to diagnose a problem here. We're just changing out some of the major components. So it's just quicker and easier, rather than unhook everything and then try to figure it out on the schematic where it's supposed to go. It's just faster and easier to mark everything with tape or draw a diagram or something. So that's what we're going to do now. Alright, now the type of multi-stage capacitors in this amp are what are commonly referred to as twist lock, which it's kind of a differentiation on how they're mounted to the chassis. So as you can see, it's kind of hard to see in the video, but each different stage of the capacitor, there are 3 in this one, have their own lead terminal here. So these are different, basically different capacitors inside the multi-stage can. And the label here on the outside tells you what the capacitance is and its voltage rating here. And each stage has its own symbol. So you have like the half moon, the square, and the triangle. And those are also marked on the bottom side here, which is also hard to see, but there's a triangle there, the square, and the half moon shape. Now the twist lock feature is actually these 4 tabs that are on the outside of the ring circle here. Now these actually slide through a mounting plate, which is this. So this is mounted to the bottom of the chassis of the amp in these 2 holes here. And then you slide this through, and the tabs on the capacitor match up to the mounting plate. Okay, so this is sort of a model of what it would look like. Now these 4 outer tabs, then you take a pair of pliers and just literally twist these. It doesn't really matter which way, counterclockwise, clockwise, it doesn't matter. You just twist them 90 degrees to one side, and that's how these things are held in place. So for this project, the capacitor kit came with these mounts, which are nice, but so this is the hole in the chassis where that capacitor came from. Now you can see that it still has the original mounting plate in here, and it's riveted to the chassis on each side. So this is like a factory job. Now, to remove these rivets, I would have to get a drill and ruin one of my drill bits to drill through this rivet and then install the new one with hardware and all that, and that's just more time and effort, and frankly drilling rivets is my least favorite thing to do in this whole world. So what I did is I carefully removed the original capacitor, leaving this intact without breaking it, and this is going to be perfectly fine, and it matches up perfectly to the new capacitor. So that's what I'm going to do. I've made that mistake before where I just wrenched this thing out of here and broke the thing, and it just cost me a lot more time and agony to finish the job. So this time I wised up a little bit, and I'm going to save this original mounting plate. Okay, so we have the new capacitor mounted now, and as you can see, the twist lock tabs here, all four of these, are twisted no more than 90 degrees. You don't want to wrench these down because you'll end up breaking the tabs, and then that is going to suck really bad. So we just turned each of these 90 degrees. It's secure, mounted to this plate, this bracket, mounting bracket, whatever you want to call it. It's not going anywhere, so we're going to start to wire this one back up. And I did make me a little diagram, however crude it may be, but this is the capacitor that we just changed out. This is the one that's right next to it. And I've got the symbols that correspond to each terminal on each multi-stage cap, and then just what wire is going where, and there's a couple of 2-watt 100K resistors that cross between them. This one goes to ground here. These two caps, multi-stage caps, are actually sort of wired together and serve as one giant capacitor, if you will. So that's not really important here for our purposes today, but so I've got all these wires marked and what terminal they're going to, etc., etc. Pretty straightforward. Also, as I'm cutting these wires off of the terminals, I'm going ahead and marking them just to make sure I know where they're supposed to go as a fail-safe. Just an extra step of insurance. Alright, so we've got these two brand new multi-stage caps installed and hooked back up, and those resistors that you see are new. They came with the capacitor kit, so I went ahead and switched those out too, and we're gonna move on to our next step here. Okay, so now we are moving on to our next and final step in this repair. So I've installed these new power tubes. This is a matched quad of 7581A type power tubes. Now, this amp originally came with 7027s, but these are in the same family. It's basically the 6L6GC family, so you could put 5881s in this amp. You could put 6550s if you wanted to. You have to make some modifications for those, as well as EL34s. But these amps were designed to be very versatile and give you a lot of options on what power tubes you use, depending on what kind of music you play and what tone you're trying to get and so forth. But the most important thing is you have to check the bias. Anytime you install new power tubes into an amp, you have to reset the bias. So that's what we're going to go about doing right now. Also, the 7581A has a plate dissipation of 35 watts, whereas the 7027 has a dissipation of 30 watts. So these are going to technically put out more power, My client was actually trying to get some extra clean headroom out of this amp, so a little higher wattage tube in theory is going to produce some louder clean tones, but because the tube is rated a little bit differently than the stock tube, we're definitely going to have to adjust the bias on this. Okay, first thing to remember whenever you're checking the bias or whenever you have an amp turned on, pretty much in general, you need to make sure you've got a speaker load in the output jack. You can use a dummy load if you have one, but the output transformer needs to see this ohm load here in order for the amp to work properly. And I'm going to use this bias probe here that's made by Eurotubes. You can get these online for about 30 bucks. It's a really nice tool to determine how much current is being pulled by a particular tube. Really helps you in biasing the amp. Now I've got one multimeter here that's going to tell me what my plate voltage is. That's going to be an important thing to know in order to figure out what bias current I need. Now the plates on these tubes, just like a 6L6, is on pin 3 of the power tube. So rather than try to get a lead clipped onto actual pin 3, I'm clipped onto this plate resistor here. It's just a little easier to get to, but it's going to give me the exact same reading as it would on the tube itself. And since this is the first time I've turned on the amp since I reinstalled the caps, I'm going to bring it up on the variac just to do it slowly, make sure we don't see any smokes or sparks or anything like that. So here we go. So what you're looking at is the plate voltage of the power tube there. Okay, we're at about 75% power now. Okay. Now we are at 100% power. About 522 volts. That sounds about right. Okay, looks like it's settling right around 526 volts on the plates. So we're gonna remember that number, we're gonna write that down. Now, so we know the voltage that the plates are getting, it's about 526. Now I wanna check the negative voltage on the control grid. Now this is what basically keeps the tube from burning itself up. So we got to have the proper negative voltage, and on this schematic it's negative 62. So I'm using the variac again. I'm bringing this guy back up slowly, and we're going to want to see a number around negative 62. Okay, so we're at full power, and that's pretty damn close to where we need to be. And it's actually probably okay because the schematic also calls for the plates to be getting 540 volts, but we're only getting 526. So this looks good to me. Okay, and we're seeing about 34 milliamps of current being drawn on the power tubes. Now, normally this would be fine. Typically anywhere between, I don't know, mid 30s to 40 milliamps is good when you're biasing a power tube, but since these are 35 watt tubes, if you do the math at 70% dissipation, you want to bias your tubes at about 70% of their max power so they won't burn out as fast. But I did the math on this and it looks like we want to see about 46 milliamps of current on each tube, so I'm going to have to make an adjustment here, and that's kind of a bummer, and here's why. The Ampeg V-4 was not designed with a bias pot, so to change the bias significantly on one of these, you have to change out this resistor right here, which is R49. It's a 75K resistor. So what I'm probably going to do is change it out with a 60K to allow a little more current to go through here. It's a bitch because you have to just take this thing out and install a new resistor. It's not very convenient, but that's just the nature of this beast. So that's what we're going to do now. Alright, I ended up having to basically rebuild the entire bias section in this amp. It makes sense. It wasn't wanting to hold bias. The tubes were wanting to red plate. And if you think about it, you know, you've got a brand new power section, you've got brand new power tubes, and then the bias section is pushing 50 years old, and it was all original components. So I had to basically rebuild the bias section from scratch. So that's all of these components here in this section. I was hoping I wouldn't have to do this, but I equate old amplifiers oftentimes to old cars. When something breaks on a car, a lot of times you fix it and then other stuff around it starts to break too because it's aging, and the new parts actually put more stress on the old parts. So anyway, it is what it is, but now we've got a completely new power section, bias section, and also the screen grid resistors up here that I put higher values in. It was 470 ohms on the schematic, but I went ahead and put 1K ohm resistors in each of these positions. So this amp is going to last for hopefully another 40 years with all these updates. Alright, well that wraps it up for today. Thanks so much for watching the video. If you have any questions about what you've seen today, just leave it in the comments below. I do my best to answer any questions that might come up from viewers. Like and share if you care to. Otherwise, we'll see you next time on Armchair Technician.